Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
We're going to get to that. Okay, so part of this is to talk about these sorts of things. I'm going to give you a really bad answer. Okay, so here's Okapi BM25 if you're not particularly familiar with it, but it's really just a way of taking a whole bag of statistics and throwing them together, document and term statistics, throwing them together in a heap and saying, this is the right one, primarily based on the content. So I'll pick out a few pieces of this just in case, like I say, some people will be familiar, some people won't be familiar. First of all, I just want to point out that the contribution, so there's a query which is a bunch of terms. So I got to get my thing here. There's a query, and query is just going to be a set of terms. A component is going to be any of these things. So the X can be a paragraph, X can be a section, anything else. And I'm going to score that component by basically each term in the query. I'm going to compute a particular value related to that query. But I just wanted to point out that then they're completely independent. So there's no there's complete independence between how much, say, this query term contributes to the score versus that one. And that's something that's sometimes a little bit surprising about this. Now remember, as I said, this is probably the best standard method for doing this kind of stuff. Where I'm going to actually do my influence is here. So what this is for a particular term, let's say text or compression, we're going to look at the number of times it appears in the component. Okay, so that's just a recording of the number of times that text appears in this particular paragraph. And that's actually going to be the place where I'm going to, when I try to adapt this to do re-ranking, this is going to be the place that I'm going to do the re-ranking. I'm basically going to foreshadow this. What I'm going to do is say, once I've reported this, the importance of the terms within this component decreases a little bit. Okay, so I've already reported this particular paragraph at a high rank, so its contribution to the document as a whole is going to be reduced a little bit. And where I'm going to do that reduction is I'm going to do that reduction at that point. Now to adapt these methods to all these individual little components, okay, I have to have, so this method depends on essentially inverse document frequency. It depends on the number of times the total number of documents in the collection. I'll come back to that word in a second. The number of documents in the collection, and then the number of documents containing that particular term. So if very few documents contain a term, it's a really important term, right? Very unusual names, things like that. The word "the," on the other hand, is in almost every document, if not in every document, right? In which case, its influence is very, very minor. And this is a pretty standard TF-IDF type relationship, where the sort of genius of BM25 is in this part here. I mean, it both has a lot of sort of reasoning behind it, but this part was the part that sets it apart from earlier methods. And this is still a fairly mature thing that's been around in this form for about 7 or 8 years.
You're dynamically re-ranking.
Yeah, we're going to get back to that. I did say I was going to mention this documents here. Actually, this is one of the places. So this needs a lot of tuning to get it to work well in this kind of environment, or a reasonable amount of tuning. For this particular experiment, I just said document to mean article. And I think that was the wrong thing to do. And what that tended to do is make it go more toward components that sort of cover the topic completely, rather than smaller components that narrowly focus on the topic. So in one of the places I'm going to play around with this is change what I mean by document for this number. And different people at IBM Research and things have played around with this a little bit more than I have. And finally, here at the bottom, there's a couple of rather completely arbitrary parameters. And these things usually, people who work with this, the characteristic of English and things sort of sets this at being, and the characteristics of the collections and queries we typically use. And admittedly, these collections and queries are a little bit, they're informed by reality, but they're not completely based in reality. These numbers here tend to be sort of in certain ranges, and I'm used to setting this to 1.2 and this to 0.75. And in fact, the 0.75 still works. It was very interesting that to get this to work properly, I had to tune the K1 out to an area where I sort of hadn't done that before. So what we did to tune this is use older queries to sort of adjust this stuff. And I'll come back to this as well, but this was something that other groups have seen with other retrieval models, that to get the baseline retrieval methods to work very well, you have to do a lot of very strange parameter tuning particularly related to length normalization and things like that. So here's basically if I take, so what I've done, it takes a little bit of work to, and something I'm not talking really about at all, is sort of, I don't really want to, what I don't really want to do is break my collection up into millions and millions of individual pieces and treat each one as an individual document and compute term statistics statically on those things. I have to compute it dynamically. So there's a whole part of dynamic computation of the term statistics I'm just leaving out. That's something where we have okay performance on that. But the important thing is that you can reasonably do this where you don't actually have any more overhead in your index than if you just index the individual articles. So this is what actually comes back from our system. I went into the middle of it and grabbed out a snapshot.
Can you just say, like, if it's a 30,000 foot view, how you do that? You can do
Oh.
statistics below, so and accumulate up.
So actually that's one way you could do it. What I do is I basically view, I split the tree in slices this way. Okay, and then you get a particular component, and you can take your index list and sort of see whether there's a term that jumps into this component or jumps into another component, and then you can look at the range in your one list that fits into this component, and that tells you the term frequency in that component, right? And then you sort of take the next one and jump ahead into the next, but it's taking things, cutting it this way, right? So rather than going up and down the tree, right? I will go up and down the tree for another part of this, but for the sort of core part of it, I'm jumping around. Right? So here's the raw output, and you can see here that basically we really only have 3 documents here, right? So we get the article and body from this, and then a couple of sections from that. This is actually the journal article that I showed you a few minutes ago. That's repeated, and here we finally have a new one. So this is exactly what you'd expect from this. Right? And these are the Okapi scores over here. So this is just something I clipped out of the middle of a file and threw up here. So in the overall overview, the baseline retrieval method, basically taking standard IR method, adapting it to this problem, a little bit of trickiness to try to get each component represented as a separate document, a little bit of trickiness to try to adapt the Okapi BM25, but really not very difficult stuff. So now I want to talk about evaluation methodology, and I'm really now going to start talking about stuff that I participate in, not stuff that I'm sort of the principal behind. So there's an evaluation initiative called the Initiative for the Evaluation of XML Retrieval, INEX, and this is a sort of IR for XML version of TREC, if you're familiar with TREC, and it's the IR version of XML if you're more of an XML person. So basically the idea is that there's about 50 participating groups now, and there's a number of tasks. And the one that I'm talking about is called the content-oriented task. There's also a content and structure task. And really this initiative, though, one of the things that was good about TREC is that at the point where they initiated TREC sort of 13 or 14 years ago, there was a very clear proposed evaluation methodology for IR, right? There was going to be this pooling method. They were going to do very specific things. But as part of this, there's really no good evaluation methodology for IR over XML. This doesn't exist. So part of the effort is to try to develop good methodology. And one of the things I'm trying to do by this is to actually try to push the methodology into recognizing that essentially not all overlap is bad. So what I'm talking about is really derived from, at least what I'm talking about up until about the middle third of the talk, middle 2/3 of the talk, is this content-only retrieval task for INEX 2004. We have a small-ish text collection. It's all the articles in IEEE, computer and journals, I think, and a few other journals between these dates. So it's a relatively small collection in that it's only half a gigabyte. Okay, it's a relatively small collection in that it's only equivalent to the complete works of Shakespeare or something like that. But it's a fairly large collection in that it's the combined research output of lots and lots and lots of people. So there's lots of good content in here. But by today's standards of searching, 400 terabyte kind of things, it's actually trivially small. But it's a good place to get started, and I think they're going up to a much larger collection next year, at least for some of the tasks. There are 40 queries in this task, and these are made up actually by created by conference participants and then vetted by the conference organizers, so there's some collaborative effort to create new topics. Here's your typical query, and there's some explanation of what makes a relevant component versus a not relevant component. And if you're familiar with Trek, it's structured very much like Trek. So you run all of these queries against your own system, you submit runs, and then there's a sort of mutual evaluation to see who did well and who doesn't do well.
How are the relevant? Are you going to talk about relevance assessments at all?
Yes, right now. And in fact, relevance assessment is something they've been struggling with. This is Munir Lamas and Norbert and people like that. And this is something they've been struggling with for quite a long time. So in a regular IR task, you can sort of say, and this only in part applies to certain web-related tasks, but the general way of doing it is basically you have a document and you say this document is relevant or this document is not relevant. Okay, and this can be different degrees of relevance, but basically it's yes or no, and that's generally the approach to evaluate. On the other hand, if you think of evaluating individual components, then we get into the problem of, well, okay, so I have that huge article. The whole article is relevant, right? And the first section is relevant, and the second section is relevant. The third paragraph of the 15th section is relevant. The abstract is relevant. So what does it mean? And in fact, we can just say everything's all equal, like they're all equally relevant. So this obviously is not the best way to go. So INEX defined two dimensions for relevance. One is basically the degree to which the component covers the topic. So how much does it cover the topic of text compression or software quality or something like that? So how deeply is it covering this topic? And then the second dimension is the degree to which the component is focused on the topic. So if I think of, say, a list of product reviews from IEEE Computer, right, the whole thing is relevant to text compression software if it describes text compression software, but the whole set of product reviews is not very specific. On the other hand, the specific review of a text compression product is in fact very, very specific. On the other hand, it may still only be partially exhaustive because it's only covering a few aspects of that particular idea. So they have this 4-point scale for both, marginal up to, well, from not relevant up to marginal and then up to exhaustive in both ways. So you end up with 10 possible judgments where 0, 0 means not relevant at all, 3, 3 means highly specific and highly exhaustive, and then there's intermediate values. 1, 3 means marginally exhaustive and highly specific, and 3, 1 means highly exhaustive and marginally specific, and things like that. And this model actually sort of captures things reasonably well. So you can think of, if you have all of an encyclopedia, it's highly exhaustive about lots of things, but not very specific. If I have sort of one sentence out of an encyclopedia, it's very, very specific, but not very exhaustive. And so the idea is to look somewhere in between. On the other hand, the assessor agreement here is relatively low. And there are two, in INEX 2004, there were two evaluation metrics used. This is the official evaluation. And strangely enough, they've had so much trouble dealing with the overlap that they basically just evaluate these systems by saying, well, it's all good. Okay? So they basically do a evaluation that says, even if you're getting highly redundant things, we're going to give you credit for the highly redundant things. Okay? And so this is a version of mean average precision, okay, which is a standard IR measure. And it's been adapted in a number of different ways, but the basic takeaway from this is that we're still going to count, even if it's redundant, we're going to still say it's all good and we're going to give credit for the redundant thing. So there's a number of different quantizations here. I don't want to go into this because this could be a whole talk by itself, arguing about how terrible these things are. But they then, in the basic mean average precision, they give credit for different kinds of things. So there's a strict quantization that says the only things we're going to count are the 3, 3 elements. Okay, we're only going to give you credit for the 3, 3 elements. And then there's other versions where they basically give you partial credit for, a 1, 3 element gives you partial credit versus a 3, 1 element giving you partial credit and things like that. But the takeaway from this is that this is not penalizing overlap at all. Okay, certainly this does in the sense that it's unlikely to have sort of 3, 3 element with a 3, 3 deep component, but it's not directly designed to penalize overlap. And then this is the official metrics this year. They've also introduced this thing at SIG-IR 2004, which was this XML accumulated gain metric, XCG. And what this does is the opposite. What it does is says all overlap is really bad. We don't want along any path, there's like an ideal component. This is the best component along that path. And what we're going to do is come up with an ideal answer, an ideal gain vector that says, here are the things you should report. Basically, this ideal vector eliminates all overlap, and then what you get is you get your scores based on how closely you match that vector. So if you have something that's too big, you lose credit. If you have something that's too small, you lose credit. And if you're sort of, Goldilocks, if you're too big, too small, if you're just right, you get the full credit. And so there's a paper in SIG-IR 2004 about this, and this has been talked about also in the same paper where they were contrasting these two things. So
is the last one identifies the level of analysis is ideal for this theory, and then everything
yeah.
above or below that is generalized?
Yeah, so it says this is the right component along this path, right? And then anything above or below is no good. But the takeaway from this, and as I say, I could give you a whole talk just on these evaluation metrics, but they're not really mine. The takeaway from it, and this is very crude, so I apologize to anybody who might be out there on that camera who's involved in these things, but basically mean average precision is going to reward overlap. So it says, I'm going to, if you tell me, you find a relevant document, if you give me the abstract to the paragraphs and the sections, all the separate documents, I'm going to give you credit for all that. That's really good. And if XML accumulated gain basically penalizes the overlap. It says, if you give me overlap, I'm going to penalize you for it. And this wasn't an official metric, but as it turned out, we did actually, I actually submitted runs which were appropriate for both of those, and we'll come back to that in a second. But neither metric sort of says there's a good and bad overlap. None of them says this element up here is a good general thing. So this is a 2-3, this is a 3-2. We want to give you both. Right, and that's sort of where I'm headed with this little talk. Now that I've defined some evaluation metrics, I just wanted to drop back for a minute. This is one of those parameters. So this is actually mostly just of interest for people who are strictly in IR. But it's interesting, this parameter. We did very good in measures that emphasized the exhaustivity rather than the specificity. And I think that relates to how I picked articles to be documents for my IDF values. But this point, which is very close to where the baseline, the sort of usual values or default values for Okapi, you sort of get this kind of performance, and this is a mean average precision value on older training data. And this is sort of the best. So this is a sort of mediocre performance, and this is like top-notch performance, and the only difference is in the tuning parameter, right? So as I come up this, changing the value of this rather arbitrary thing, we're going from sort of not really very good performance to the sort of best performance there. I think I'm trying to remember. It gives more credit. It means that extra. I think as it gets bigger, it means extra copies of this count for more. Is that right? So these things are very hard to relate to any.
Less squishing than you would normally do.
Yeah, less squishing, I think. Which is probably why it does well for exhaustivity rather than specificity. Okay, so I have 3 map measures here. I'll look at 2 of them. The strict one is the one that gives you credit for just those things that are 3-3s, highly exhaustive, highly specific. So relatively speaking on those, we did pretty good. But remember, I'm not touching overlap here. But so within that run, there's 70%, 6% overlap, which I'm struggling to understand what they mean by that, but I think it means that within the top 1,500, 70%, 6% of the elements overlap with some other element, top or down. Okay? But I was groping around several times in the last week trying to understand how they really compute that. It's obvious that high is more overlap and low is less overlap, but exactly how they were computing the percentages I could never dig out of their evaluation. So that's not really a principal evaluation measure in any case. So the same run, the one with lots of overlap, even on generalized ones where you're getting credit for partial hits, we still do fairly well. So we're sort of tuned toward the strict, but we're doing well on other evaluations. On the XCG, though, this is the same run with 76% overlap. On the XCG, once again, the top 5 runs doesn't look so good. Okay, top 6 runs, that looks a little better. But this is not the same run that I had before. This one's actually been filtered. I was working on this last fall, and basically I did a filtering that said, all right, if when I get a component, I'm going to eliminate everything below that. in the run. So it's a very crude filtering approach, and that does pretty well on the XCG, but the overlap has been filtered down to 13% by eliminating the children. But you notice these are actually different groups. So if I pop back, right, and it's all usually, if it's the same group, it's different runs. So for the first two, it's going to be the same run. Haifa does usually well. This is a French group, and so on. And so same people. This is Jamie, one of Jamie's students here, but Tempore, who spent a lot of time trying to sort of filter things out, popped ahead there. So, yeah, they did. That's Jaap Kamps and Martin Derijke, and then I don't necessarily know. I don't actually know the people at Berkeley. So, and this is, I think somebody. I don't think it's Cal, but it's somebody that's in the same group. So now I'm back to the re-ranking, and so now I've sort of reached the point where I'm moving out of sort of things that we've done and into sort of stuff that I'm working on and completed in part. So where we are is we sort of said, we're going to split this up and treat everything as an equal document. This is a sort of standard approach in the INEX community, and it works pretty well if you tune things appropriately. Evaluation is a little bit of a mess, but that baseline method with the evaluation techniques that they have can be made to work pretty well, either by eliminating all the overlap or not having all the overlap. So now what I want to do is I want to just say, okay, well, really what we want to do is we want to sort of say, well, what's the good overlap and what's the bad overlap? So I want some kind of systematic approach to doing the re-ranking. So that's why I start with the baseline, start with the baseline ranking, ordering of all the documents, all the components. And now we're going to do some sort of re-ranking that eliminates the bad overlap and keeps the good overlap. And we want to do that in a very systematic sort of way. So here's a bunch of words. But basically the idea is I'm going to start with the initial ranking. As I said earlier, I'm going to keep the best guy, okay? Re-rank, see what influence that has on the remaining elements, take the next best element, see what influence that has, and repeat. Okay, so we're going to basically iterate to adjust the scores. So the technical part of this is how I'm going to adjust the scores. And here's the picture that you should have in your mind for doing this. So this is one of my many trees in the forest. And what I'm going to do initially is I'm going to get an initial ranking of components. Okay, and I didn't want to sort of decorate the whole thing. But, we got the idea this one sort of ranks very high because it's fairly focused. And then in turn, this, of course, is also very focused and is going to rank very high. But when I put these together, because maybe there's lots of extra text that's unrelated, the ranks go down. But as a whole, this is pretty good. So what I'm going to do is I'm going to say, well, within this, and there are other ranks as well. So this happens to be a really good document, but there, 5 is missing and things like that. So I remove this element. I say, so this is sort of the high-level picture of it. I say, okay, this is number 1, so I'm going to report number 1, the first thing I said. So now I'm going to sort of say, well, what's the influence of number 1? So you can really think how I sort of thought about this is you're sort of graying it out. You're saying, well, it's not as important, but it's still there because it's contributing to it. So the graying out of that is going to have some influence on the remainder, right? So it's going to reduce the content of this, but still this is here. Maybe this has an influence over here, which is why it stays at 10. This is all.
Gray out number 1. You literally remove those terms from everything you do, or something.
So I'm sorry, my shoe is untied here. So I'm not going to remove them in their entirety. And in fact, I'm going to sort of come back to exactly how this is being done. And it's being plugged into the Okapi measure in the place that I said it was going to be plugged into. So, but conceptually, I'm graying it out. I'm not eliminating it. Okay, I could be eliminating it, but I'm sort of conceptually graying it out. And so now I take the next best one. I say, well, this is still good because there's been no influence here, of course. So I gray that out, and that adjusts the scores again. Then I get number 3, number 4, number 5, and eventually I get back to number 21. And once I report number 21, then that really has a major impact on the whole thing because at some level it's going to gray the whole thing out. Now, right now I just have one parameter in the sense that what I've talked about. Basically, the idea is once you've reported something, I'm going to gray it out. But I will generalize that at least a little bit before the end. So to go back to the re-ranking algorithm, we basically have a priority queue ordered by score. We're going to report the highest ranking component and then sort of pull it out, and we're going to walk up and down the tree, right? And as we encounter nodes up and down the tree, you adjust you find them in the priority queue, pull them out of the priority queue, adjust their score, put them back somewhere else in the priority queue, and repeat this over and over again. And there's some sort of modest amount of trickiness to make sure that the amount of work you're doing is not enormous, so that there's some in both the sort of simple version of the algorithm and the generalized version of the algorithm, there's a certain amount of trickiness to make sure that you're not, when you pull it out, if something's got lots of children, you pull it out, you're going to work with all these children, re-rank, and then you pull out its parent, you end up working with all those again. There's a way to control stuff like that, but the basic idea is I'm going to work up and down the tree. So there's two parts to it. One of this is sort of the re-ranking to, if I had to sort of characterize the contributions here, there's apart from just sort of, how to tune things up to make Okapi BM25 work really well, there's the sort of idea that we're going to do these adjustments, but also how the adjustments are going to be done. And I was sort of inspired here because there was a couple of excellent papers by Steve Robertson's group at Microsoft Research Cambridge about adopting Okapi BM25 to the problem of document structure. So not the specific problem I'm talking about, but rather how we differentially weight terms in the title versus terms in the body of an HTML document, as an example, and terms in the anchor text, things like that. So they did their adjustments at this level. So this is the point where you're counting the frequency that T occurs in a particular component. Okay, so this is the point. So sort of an alternative to this, a fantasy way to do this, is that when I see that this component is really good, I'm going to take its score and somehow subtract it from the scores of the other components that contain it or are contained within it. But if you can't really linearly combine these Okapi scores in this way, even if you try to weight them or play with them, they don't really work. But where you can linearly combine things is at this level here. So basically how they did it in the original work was to say a term in a query counts as if it's 3.2 terms, and a term in the body counts as if it's one term. Right? So the weight was applied at the point where we're mixing the importance of the terms together. So I'm going to do the same thing here. I'm going to say, in this simple model where we're just graying things out, I'm going to say if you're grayed out, you count for some factor less than you would count for if you weren't grayed out. So I'm going to take this frequency that term occurs in a component, and I'm going to split it in two pieces. I'm going to say that there's the sort of baseline frequency. So here I have a baseline frequency that T occurs in X. So this is the same as what we had before. This is the on grayed out. And then this is a measure of how many times not how many times, sorry. This is how many of the terms are in grayed out parts of the document. Okay, and I can put these together with just a little linear weight. So this is the simple version of it, where my picture of what's going on is just that I'm graying out part of the document and letting that have influence on the term statistics within the document. And so everything else in the Okapi is the same. Okay, so how does this work? Example with alpha equals 0.5. Okay, so my initial term statistics at 2 nodes, for example, for a particular term, I don't know what this is, since this is completely fictitious. It's compression. Okay, yeah, there you go. This is compression. In this particular component here, which might be a subsection, we have 6 occurrences of the word compression, and because we haven't sort of grayed out any of this, it makes its full contribution. So then this is my number 1 component, this is number 21 or something like that. So when I decide that this is the number 1 component, of course, then it gets grayed out, and then the algorithm is going to propagate this up and down the tree. So we're going to propagate this up the tree. So the effect of this is going to be turning this into a 6, which will make that into a 10. Okay, so what we've done is taken the fact that this is grayed out, sent it up there, and so there's obviously some tree walking and things that have to be done, and we end up with the data structures. It's not very complicated. There's a priority queue and some trees and things. So as I said, just to sort of flesh this out still more, we're going to keep our tree nodes in a priority queue, report the component at the front of the queue, and then propagate these adjustments up and down the tree. And as we propagate them, we're going to take the nodes out of the priority queue and put them back in. Okay, and then this M actually turns out to be really important, because if you try to re-rank the whole thing, you end up doing tons of work. But if you say, well, we only want the top 1,000 or something like that, then that becomes a, if I sort of work out the time complexity of the algorithm, this becomes a sort of significant parameter in the time complexity. But there's various simple ways to limit the amount of work you have to do as you propagate it up and down the tree. And so all this can be generalized, which I'll do in a minute, because just to foreshadow once again, you don't really want to just gray it out, right? The first time it's reported, it's good. The second time it's maybe not so good. The third time, the fourth time, whether it's in the parent or the child, we want to take into account all this. But even this has an interesting effect. Oh, I didn't step through that. What I have here is these two metrics, which I didn't really introduce particularly well, but I gave you the basic idea. Mean average precision as interpreted by INEX rewards overlap. XCG, this relatively new message, penalizes overlap. And so I have this alpha parameter here, and I basically just roll it from 0 to 1. And as I do that, as not too surprising, I get the effect of going from over here, sort of among the best groups doing the retrieval, to sort of the best groups over here, just by adjusting this parameter. So this is hardly surprising, but it's sort of like, well, I don't have any better metrics. I don't have really good metrics that recognize that overlap may not be a bad thing. So all I can do at this point is sort of say, what's the influence on the standard metrics? And the influence of that single parameter on the standard index is to sort of get us from terrible performance in one metric up to excellent performance, and vice versa. So, well, why don't we set it in here somewhere, but I don't really know what that means. Right? It might be good, might be bad, I don't know. Okay, so part of doing this, and it's sort of complete in the sense that all the re-ranking is there, but how this should be turned in for evaluation is still a little bit up in the air. One of the things I want to end with is sort of an overview of how to extend this. So as I said, one parameter is probably not sufficient, because there's two things. One, I want to distinguish between being reported in the child versus being reported in the ancestor. Okay, and these may be very likely to be different, right? And in fact, I want to generalize it completely. I want to take it in the sense of, first of all, how much of my children, for a particular node halfway down the tree, how much of my children have been reported and what the influence of that is, plus if my parents been reported, then that's going to reduce overall the sort of level of importance of this component. And then if, in fact, the article was reported and the section was reported, then that really should have a bad influence, or significantly reduce or substantially reduce the influence of the terms and the things underneath. So I added a whole bunch of these where basically the subscript here is counting the number of times that it's been reported in an ancestor. This is the sort of all the terms and descendants that have been reported are wrapped up in alpha, and you can put all this together into that. And this is sort of, and then taking this, you can use an and am, and they become the parameters and the time complexity and stuff like that. But the basic thing is that I can't really train this or use this, because I actually don't know what I'm training or what I'm trying to optimize, and that's the thing. So what I'm trying to figure out now, I have a solution, and I'm wandering around saying, well, okay, and I think there's a problem, but I don't quite know how to fully describe the problem. Yes. Right, so if I had something that matches, so I mean what my plan is for INEX next year is to take the XCG and tune this set of parameters to XCG, because that's going to be their big metric. And if that means that, in fact, these all come out very close to here, and this comes out to very close to 1, what am I going to do? But at least I have a set of things that I can tune. And if I can get if I can think of a better way to express as an evaluation what I'm after, then I can if we have a different objective function, then I can adapt these parameters to the objective function. So some conclusions. I actually want to do my conclusions in two pieces, because this is one very small piece of several different things I'm working on. But in this particular thing, I really want the takeaway addressing an IR audience is to sort of say, well, overlap isn't always bad, and the idea is that we have to figure out a systematic way for controlling it rather than eliminating it. Some sort of, if people that knew a lot about sort of the people who have been sort of, actively involved in playing with Okapi were around, they'd say, no, that's not right. You need to modify K1 to, reflect. Someone from Steve Robertson's group was here. They would probably criticize this part of it, and I sort of agree, but I'm not exactly sure how I should do that. So for the work they did, K1 would vary depending on the relative influence of the title versus the body, for example, and that's something I should do. I've also been playing around, because so this is sort of from the algorithmic standpoint. From a
You didn't really take into account the document structure.
not in the ranking, no.
Right.
It's more just, has it been appeared or not, right? That's the key thing. And certainly you could do that. You could actually then also have different, weights on abstracts versus bodies. And certainly some of the results I showed you earlier, it put the body before the whole article, which is probably not the right thing to do. And if you could put weights in that reflected the fact that, but once again, there's a whole bunch of things to learn, right? And I have a relatively small amount of data. I had a student. Most of this stuff I sort of have been doing on my own, because we have a huge tool set at this point to do these kinds of things fairly easily. But I had a student that was just playing around a little bit with clustering these things as opposed to re-ranking them. And that actually wasn't very satisfying, but I can show you why it isn't very satisfying. So that's sort of one of the things you could do. You could sort of say, well, no, this isn't right. You don't eliminate them. You just say, well, this is the really important one, and here's structurally how everything fits. But it's still in this sort of mass of sort of cluster of related elements. You want to say, these are incidental, and this is the important one. So you might want a cluster of one or two things, not a cluster of every component in the relevant article. And then, the motivation now is, well, what influence does this have on the evaluation methodology, and also on learning these parameters? But to be perfectly honest, this is sort of not how I see the sort of ideal version of XML IR to work. Can I borrow that book? Is that yours, or is it just sitting there? Okay, here's my test document, right? So here's how I sort of think it should work, right? Oh, it's a product catalog. So this is a product catalog. So this is not the kind of XML data I'm talking about. This is your classic DB XML data. But I've broken it. But really what you want is, you're not really sort of saying this is the right component. What you really want to say is, you want to turn to your thing and say, well, here's the part of the document that's relevant. Here's the part of the document that you want to read. And then identify this as a passage. Identify this as a part of the document. And then move up the chain looking for the appropriate component to report. So, identify it being these three, and so this is now gets you the kind of answer that you want. You discover that here, this is the relevant part, and the thing that contains it are these three paragraphs, right? So now that I can come back with a more generalized result and say it's these three paragraphs that are the right answer. And actually, trying to express that in something like XPath turns out to be annoying, at least the XPath I know. But you could do XQuery or extended or whatever. But that's the kind of result you want. So I could not generalize what I'm doing now to report triples of paragraphs, because instead of having sort of all these individual components as documents, I've got all these individual components squared as documents. And so then it actually does become intractable to do it that way. And if you do want to be able to report the more useful result that these, and this is something we did some digital library work a few years ago, and we had very long documents, very small documents. And what we really wanted to report was these 3 pages, right, as the answer. And from that, you have to start at the passage level and work up, rather than try to start at the component level and work down. And I just wanted to throw that in because in sort of going forward with XML IR, that's more the direction I'm going to be trying to head in. So this turned out not to be a great prop. Exactly the wrong kind of prop. So
The bottom up.
Yeah, the bottom-up approach. So start by saying this region of, this is treated as no structure at all. You just have, a long string of prose stretching out to infinity, and you walk into it and say, this part, and then, this part down here, and this part over here, these are the order, and then try to work up until you find something reportable that's, an acceptable type, piece of the structure, which might turn out to be the whole book, or it might turn out to be just a paragraph or something like that. Okay, that was the end of what I was going to say. I seem to have hit the time pretty good. So. Verify. Well, this is this sort of like all the websites publish their RSS stuff, and whether that you know whether this is going to have any influence.
Yeah, I mean, there's kind of the using XML documents. I don't know how often you see those. I can even kind of imagine the XML if it's written, get pretty flat after a lot.
Yeah.
Whereas there's a lot of RSS feeds out there.
Yep. But the RSS feeds tend to be, I mean, they tend to be summaries of what's been posted on this site at a particular time. Yeah. I mean, the stuff that I see is like this.
But kind of the interesting question is, maybe XML search capacity for the RSS questions.
Yep.
How else
So-
would RSS?
So I actually, it's only accidental I'm doing XML retrieval. My interest has always been primarily in passage or so to me, you know, so your standard IR person views the world as a bunch of documents. I mean, crudely, right? And I view the world as a bunch of as just streams of information.
Right.
And I'm interested in saying here's the right part of the stream.
Right.
So my interest in XML comes from the fact that I was interested in unstructured things, right?
Yeah.
And in fact, all the tools that I have, you know, a document is just another kind of tag, right? Now, that's always been the case for sort of since my PhD, is that, you know, my system, it's just another kind of tag. There's absolutely nothing that distinguishes a document from anything else other than at some query point you say, rank the documents, right? And so,
Well,
that's not really,
right, which is, I mean, RSS is really a bunch of subdocuments.
yeah.
There's no deeper structure. It's, you know, it's flat.
Let me give you a problem. Current blog search engines don't effectively identify a sequence of blog posts, right? That's a real problem. There are people who do, okay, I thought about this week, I thought about next week, I thought about
Yep.
the week after. And that's one of the really unique things about weblogs. So the interesting thing that weblogs is talking about here is if you use the temporal patterns as some type of higher level structure.
Yeah, yeah.
Actually infer sequential posts. Say, okay, maybe I'll just take the month, maybe I'll make a moving 5-day window,
Yeah.
or something like that, and then figure out whether you should be returning one post or many, or just identifying that the blog is about this topic in general.
Yeah, so the sort of tools that I've been building for a long time, really, it's a matter of taking the stream and imposing structure on it, where the structure is very fluid, very adaptable, right? So it's not strictly a hierarchy where, you know, paragraphs are contained in sections are contained. You know, you just point to two things and you say in this stream, this is a blog entry, and you just make that up as you go on. This is a blog entry. And then at some point now, so this is really then in saying up front that I'm interested in these predefined structures. But where I think I want to go, you know, where I'm going with this and where I've always been going with this is to have basically a facility where you have your data type, you sort of define something that's not as rigid as a DTT or, you know, schema or something on top of it, and then you get out the appropriate kinds of things for the particular kind of application you're doing. You know, if you've got email in a file, then you can reach into the email and say, here are, you know, this is of email type. So within this, here are the email messages, and these are the kinds of things you want to retrieve. In your blog, you might want to retrieve blog entries or months or weeks or, you know, even particular sub-entries. Right? So that's sort of my own philosophy for doing this, which I think adapts to both of these problems. You know, so I happen to be talking about XML retrieval not because I said, you know, XML retrieval, hey, that's the way the world is going. Let me go do some work on it. It's more that I was over here, and XML sort of walked up and said, "Oh, you look like a subset of what I want, what I've been working on." So I'll talk about that. And then if I put the word XML in my title, you know, I doubled the number of people in the room. I think. Okay.
My question was in some ways, I think of this as a UI problem.
Mhm.
And so there's this full stream of text in the world, and I'm matching little components of it. And what I want to do is show to you where you want to focus your attention. And you're trying to do that automatically in some ways. And another way would be to show the structure and imagine highlighting in
Right.
different intensities
Yep.
where the focus of
Yep.
the match activity
Yep.
is, and letting the user abstract for themselves whether they want summary information. It maybe the best match is down here, but what I want to do is read the overview and then jump into it myself. So
Yep.
the question is, I guess, the extent to which people in INEX or elsewhere
You mean, are people doing that, or?
So like David Harper has this highlighted thing. Years ago,
Yep.
we did this Superbook stuff that showed in the context of structured documents where the mapping was.
Yeah, Murdy does the tile bars
Yeah.
and that kind of stuff. Yeah, no, that's not a focus of INEX. In fact, this part of INEX is not like everyone's sort of required to do this and required something to do called the content and structure. But a lot of people are very keen on the content and structure, where the natural language query is even more structured. Like you say, I want paragraphs that have blah blah blah, that sort of thing, right? Or you have some XPath like expression that you want it to match that and be ranked, that sort of thing. So in fact, I'm sort of more on the line that this is depending too much on the structure. But really this piece of research was just saying systematically control overlap, and here's an approach to doing it that has some good theoretical underpinnings, right? And it's not. I don't really want to flog this as the way to do all IR. In fact, quite the opposite. Right? This is so. I'm not particularly trying to flog this view of the world, right? And I would argue that I want to flog a different view of the world, but I happen to have this handy, and I thought it made a. It's sort of nice. It's nice to give because it gives the background and what these people in INEX are I guess us in INEX are struggling with. Yeah.
It also seems a little relevant to meta-search. So imagine you have lots of different sources of information, like web pages or structured data or structured sources like the New York Times. It seems like you might be able to apply some of these same tools to that.
Yeah. Particularly with something where there's a reasonable amount of Carta is probably a really good example in that it's there's a certain amount of a small amount of structure, and it's really there you can see there being facts that you want to pick out as opposed to things that are focused.
What about discussion? Word map,
So,
right?
Yep.
And a tree.
Yep.
And the gentleman was getting people the right point of discussion.
Yeah, and actually I hadn't thought. I mean, I don't know how well this specific thing would adapt, but I hadn't really sort of thought that as not necessarily a physical tree, but as a thread, and then using this as a way to sort of say, well, this thread and this thing in the thread, but then don't worry about the rest of it because if once you get there, you start browsing anyway, then I'm going to take you to some other thread rather than sort of treat every part of it as a separate, which I think that and not is sort of your first attempt at doing IR on net news. That's what you do at every articles, right? But if you use, so applying this at the thread level actually makes. And I think somebody was telling me about that here this morning. That
Yeah, I'll find the group that did
Yeah,
that.
okay, yeah.
I'll try. Chandra and Jesper Lynn did stuff where they say maybe Eric Bill, where
I think Eric might have been telling me about that actually when I was talking to him.
I'll find somebody.
Okay. All right. Well, thanks.
Thank you. It's a good job, right?
Charles, how are you doing?
Because this is.
Yeah, this is one of my students.
Did you want to present the guy maybe present?
Yeah.
Okay, good. So we can put something up for.
I guess 5 o'clock. What time is this? 2? I'm sorry.
Charles, where do you work?
I mean, I'll be like, see you later. Yeah, sorry.
Okay, you look like serious.
No.
No.
Versus
Eric, I'll read them by at 4. 4. Okay. I'll try to get somebody here at 2 o'clock to talk about the, or I'll just tell you at least what they did. No, this wasn't actually that kind of stuff. No, this was, Chandra,
Okay.
I'll talk about it. And so probably 4 o'clock, so.
Yeah.
would that be the easiest thing to call you like when we're done and you can
Sorry. 43.
Okay.
So, you know, give me a call and I can leave that name and
Okay.
be happy to.
Celtic value?
Yeah, I'm right at it. It's pretty good.
Yeah.
Oh, really? Really? Cool.
And
I like it when
it sounds like 3 Microsoft.
No, that's what I heard. Yeah. So, do you have time for dinner or something, or you want to?
I'm going to probably get that.
Okay, talk with them. I'll be more.
So I figured we need a talk.
Sure, can do that. It's a bit early for me actually, but
Yeah.
unless like, you know, if I just like I got a blocking call today, so I'm not sure if I'm gonna get a dinner time. That's fine. But you know, if you need things to meet up, like plus like maybe night or something.
So I got to meet the people.
I see.
Yeah. Well, we can have a coffee.
Okay, let's start it. Let's do that. Okay.
So building 43, trying to learn that these are the key
Yeah.
things.
Yeah.
The arbitrary number.
Right.
Yeah.
Actually, do you want to join us for lunch?
Sure.
You want to do that over next door?
Sure, all right.
Grab a lunch.
Okay.
And then at least it is to talk a little bit.
Great. That'll be good. Yeah, that's good.
Good. Yeah, let's do that. And
Probably like a what? Tea time for you right now?
Sorry?
Probably like tea time for you right
I
now?
don't know what time it is for me right now.
yeah, it's tough when you travel because we kept them up late last night.
Oh yeah. So you flew in yesterday?
No, I've been here the weekend, but we had like some people come up from Oregon and stuff like that.
So when I have to log off the machine. See, were you going to do the clustering demo?
Oh yeah, I can show you that later if you want. That's what that was. But
Do you want to do it now? Or do you want to do it like in my office
I
later?
can show you later.
Okay. Let me log out. I'll log off. Yes.
Also weather back there right now.